In this video, what we are going to see is refraction of light through a rectangular glass slab. What we are seeing here is a rectangular glass slab and a ray of light is incident on it. When a ray of light is incident on it, what would happen to this ray of light, and we would trace the entire path of the ray of light till it comes out. So as soon as the ray of light is incident on it, so it meets an interface. There is an air and there is glass, so it meets an interface, air-glass interface. There is like two media, and then at the interface of the two media, the light would have the refraction. So here, this ray of light would refract, that is, it would bend. But the question is, it would bend towards the normal or away from the normal. We have learned that when the ray of light is coming from air to glass, it would bend towards the normal. The reason is that as soon as it enters the glass, since the optical density of glass is higher than air, so it would bend, it would slow down. Since it slows down, so it has to bend towards the normal so that it would go out quickly. So it would bend towards the normal and then it would reach the other surface of the rectangular glass slab. As soon as it reaches the other surface of the glass slab, so it has to bend again, because again it met an interface of the two media. This is glass and again this is air. So now in this case it has to bend away from the glass slab, away from the normal, because we have seen that whenever a light ray is traveling from glass or a denser medium to a rarer medium, it would bend away from the normal. So it would again bend away from the normal and this would come out as this ray. So if we see here, there are three terms that needs to be learned. One is incident ray, which we know, and then this is refracted ray, and then this is called emergent ray. So these are the three rays that we have. If we see the angles, so this is the normal to the surface at the point of incidence, this is a normal, and the angle between the normal and the incident ray is I, whereas that is called the angle of incidence, and the angle between the normal and the refracted ray is R, or it is called angle of refraction. And when it comes out again at this point, we draw another normal, and if we see the angle between emergent ray and normal is called emergent angle of emergence. There is one important term that comes out of the analysis. If we see, the incident ray and the emergent ray are parallel to each other. Why they are parallel to each other? Because when it comes to this interface, the air glass interface, it would bend by a certain amount. So that would bend, and then when it meets the glass air interface, again it would bend away. So it bends towards and bends away. Since the interface is always air and glass here, and here also glass and air, however much it bends towards the normal, the same magnitude it would bend away from the normal. So this incident ray and emergent ray will be parallel, because whatever the bending is there at this interface, the same thing would be unbent, and then both of them would be parallel. So that's why if we project this incident ray, the dotted line, so we will see this dotted line and the emergent ray are parallel. But the point is that it would suffer some displacement from the incident ray. So that displacement is called lateral displacement, because it is laterally displaced. Instead of this light ray would have gone through without any refraction, but it had actually laterally displaced by this much because of the refraction at two surfaces. So there are 2 points, incident ray and emergent ray are parallel, but the emergent ray is displaced laterally from the incident ray by delta, that is called lateral displacement. So in the next class, we will be looking at this lateral displacement in detail.